Today we're doing mass calculations with a chemical equation. Another word for this is stoichiometry. So let's begin by reading the problem. Use the balanced equation, which you always have to have first, to determine how many grams of NO are formed from 10.0 grams of N2. So first I'm going to begin with the number that's given as a mass, 10.0 grams of N2. And next I want to think about what I'm trying to find, which is how many grams of NO are formed. Put that here, NO in grams. As I look at these two, I see that I have N2 to begin with, and I have NO at the end. Anytime you change chemicals, you know that you're going to have to use a mole ratio. And we remember that our mole ratios come from the balanced chemical equation. Now, to use a mole ratio, or to switch chemicals, I have to have each of the chemicals in moles. And I look back at my 10 grams of N2 and I notice that's in grams. So I need to first convert this to moles. To do that, I'm going to use the periodic table to find the molar mass of N2. That would be 2 nitrogens added together, or 28.02 grams of N2 for 1 mole of N2. I knew where to put my grams on the denominator so that they would cancel, and when I multiply that through, I get 0.3569. Now I'm in moles of N2. I want to make sure that I keep extra digits and don't round too much until the end of the problem. So now I'm ready to use a mole ratio to change from N2 into NO. To do that, I'm going to look at the equation up here. I'm going to find N2 and I'm going to find NO up here. And I see that for every 1 N2 that I have, I will make 2 NOs. That means that if I have 0.3569 moles of N2, from the balanced equation, if I double that, I will know the moles of NO. 0.7138 moles of NO. Now, since again my goal was to get to grams of NO, and now I'm in moles of NO, I know I'm not quite done. To get between grams and moles, I know I can use molar mass, so I'm going to take 0.7138 moles of NO, use the molar mass, which I find on the periodic table by adding nitrogen to oxygen for the mass. I see moles are in the numerator here, so I'm going to need 1 mole of NO in the denominator, and molar mass calculated from the periodic table, 30.01 grams of NO, and that's going to give me my final answer, rounded to 3 significant figures, 21.4 grams of NO. That's my answer. As a check, I could look back at the quantity that I started with, which was 10 grams, and I see I ended with 20 grams. Those masses generally should be in the same ballpark as each other. In other words, 10 and 20, not 10 and 2,000, because I am looking at masses and they should be proportional to each other. Now, for another way to solve this problem, you can look on the next page here. I'll show you what that would look like if we just did all of the steps run together. So here we're looking at the same problem, but all strung together as one continuous problem. First, we started with the mass that was given. Next, we used molar mass to convert that to moles. Next, we used the mole ratio, and that was from the balanced chemical equation that was given. Last of all, we needed to convert back to grams again, so we used the molar mass. As I go through, all of the units will cancel: grams of N2, moles of N2, moles of NO, and we're left with the units that we wanted at the end, which was grams of NO. So there you have 2 ways to set up a mass calculation with a balanced equation.